You didn't set an alarm, sorry about that.
Hi everyone, welcome. This is the session of the co-working group at IETF 126. I'm Marco Tiloca, my co-chairs are Karsten Bormann here and Jaime Jimenez there. We assume people to have read the list as discussed in today's meeting. We hope to advance the status of these documents and have high-bandwidth discussion as needed and time permitting. Not well applies, more on that later. We have two note takers, Christian and Ricard. Thank you very much. Please help them out. On the not well, this is just a reminder that you have actually agreed already to comply with the conditions to participate at IETF meetings. In particular, but not only, it's about IPR. Please disclose any personal knowledge of IPR that you have or refrain from participating in technical discussion. It's also about code of conduct, so please be nice and professional with one another. Reach out to TAD or the chairs for any question. A few practicalities. We've been recorded. If you are participating here, be sure to mute everything. You can join the full web interface or use the mobile Meetup version instead. If you are remote, please try to use a good headphone set and stop your video and audio unless you are presenting. You can use mic to ask to relay questions to the mic. This is the agenda for today. It's very packed, so presenters, please be on time. And after this introduction, there's Christian, UI path abbreviation in co-op, and Bill on conditional query parameters. Both document our post-working group last call. Then we have Ricard presenting kudos, key update for OSCORE, and I'll give an update on observe multicast notifications. Karsten has a presentation on non-traditional response forms, followed by a slot on different core topics that will be actually mostly covered by Wojtek through his slides. Then Ricard again with OSCORE capable proxies, and that completes the working group documents. Then we have 4 individual submissions. I start with a new one, Chem for Group OSCORE. Laurent presenting remotely, Yangtze discovering using DNS. We had also new submission on co-op task resources, and finally Karsten has also a new document to bring up, co-authored with Jaime, about the diagnostic notation for co-op message. Any agenda bashing or comments? None? Okay. Christian.
Hello, can I have a clicker?
Oh, we're not there yet. Still in the introduction. I thought you had an agenda bashing point.
Sorry, no.
Be your turn soon.
I'm sorry.
No worries. A quick update on the document status. We got 3 RFCs published since Shenzhen. This is interesting because the first 2 ones were published a few hours after the Shenzhen meeting, and the third one was published a few hours ago only. And well, this slide is up to date, so congratulations to the authors and the working group. And following right after, in terms of status, we have now 3 documents approved for publication on the RFC editor. 2 are bundled together in the same cluster, in fact, together with 2 more documents from the ACE working group about group communication for co-op in itself and the security protocol group OSCORE accompanying that. They are both in final review. And we also have in final review href. Looking at approved for publication in other working groups as related to core, the 2 ACE documents I've just mentioned, plus a document in IETF. I think the first one approved from IETF has also entered the RFC editor recently, terminology for constrained node networks. Also, publication requested, we finally made it, and we sent to the ASG the co-op pub sub architecture. So now it's in the hands of Mike. On post-working group of code processing, it's about 2 documents that are both in the agenda for today: URI path abbrev from Christian and conditional attributes from Bill. In other working groups related to PubSub, we had also the security profile of ACE for PubSub in co-op that was waiting for the core document to proceed. That happened, so this is now also in ACE, expected to enter the Shepherd review soon. And in the SHIC working group, there's also a document obsoleting RFC 8824 on SHIC compression of co-op headers that are completely working group plus code is expecting a few final touches before getting into the final Shepherd review steps. Other documents in core, there's been a number of working group documents updated recently that couldn't really fit the agenda for today, but they received to different extent updates. So please have a look and review those. There's also an individual submission that was updated and couldn't fit today on obfuscating the OSCAR option. And we had 5 individual submissions. The first one was presented at an interim meeting by Laurent and then brought also to the SHIC working group. I think it's going to be presented on Friday this week. But we had 4 more that are all in the agenda for today's meeting. And other documents related to core, but in other working groups. There were some updates on working group documents in ACE related in different ways to OSCAR, and an individual submission in TipTop by Carlos, and one document I presented on Monday in ACE that is in fact related to the one I'm going to present later today. Reviews, thank you very much. The trend is good indeed. I tried to list here the reviewers that stood out on the mailing list, unless I'm missing anything. And of course, we all duckies. There's a backlog. We are going to make this even at the end of the session. So don't run away. Much appreciated any review, including issues and comments and PRs on the GitHub. Great job. Please continue. Interesting reports for the hackathon. There was quite a few things happening around core. There was a project from different people, Laurent, Javier, Batul, and Wojtek, related to Young Seed. We had Mitro working on the implementation of Ascon for Cozy, but directly applied in a stack, including co-op and OSCAR for underwater nodes. And 3 more actually. There were implementations and interoperability tests of 2 Kudos implementations. Ricard will say more later today in the presentation. Also project from Lindsay, who's going to present later today the related draft on co-op task resources. And also Unicoop, I think Nikolai presented updates on the development of the unified and modular co-op stack in the Riot OS. This sounds great. Thank you very much. And just a reminder that we scheduled already, and it's all booked for the next series of interim meeting after the, let's say, summer break, but we plan to resume in September on the 9th. We should have 5 meetings until the cutoff for San Francisco. Which now brings up to the actual agenda. Christian, the floor is yours.
Hello everyone. I think most of you who are familiar with the document because I've presented it at the last meetings. So the very, very short version is URI paths can be a bit too long for some applications. So there is no, this document presents how to do this more compactly, and especially even in alignment with the IETF rules that we have for not encroaching on the URI space of our hosts. The current status is that I've received a number of good reviews and even pull requests and worked them all in. Thanks to reviewers for all of that. Most of the changes were editorial. There's one that I'd like, that's probably still editorial, but I'd like to point it out as like that term reject has a very special meaning in co-op or UDP, or like in co-op in general. And when we're not meaning that, we write refuse now. IANA has been as helpful as to provide an early review. One result of that is that text that used to be in the section for IANA is now moving into the text, because really IANA won't look at that, and we're not trying to have designated experts here. So it's just make sure the text is where it should be. And working that in is something that I couldn't yet do because I just talked to Ayana in the morning. But I hope that that can happen in parallel with the Shepherd review, which is, I think, the next step for this document. And that's it for me.
That should work. Karsten, are you up for the write-up?
Yes. I'm going on vacation right after IETF.
Okay, so then I'm not in a hurry with working the changes in. But I'll be doing it as well. So, okay. Thank you.
Thank you. In 1 minute. Wow. So the next is Bill, right? You have control. Hi. Well, it's Christian.
Much better, yes.
There you go.
Okay, hi everyone. I'm not going to break Christian's record. I've got probably a few slides here. So this is about the conditional query parameters for CoAP Observe, and the draft is inappropriately named conditional attributes, but that will change. Okay, quick status. The current version is version 13. I think I've closed all the GitHub issues. Coming to the last one that was open, that was closed just before this meeting, was issue number 59, and that's the biggest change in the draft. GitHub issue 59 was actually raised by Christian, but there's been some context behind that. There's been several mailing list discussions. We discussed it at an interim meeting, and then the other draft, section 2.4 of the draft that talked about clarifications and corrections also address this issue. Essentially, what we are looking at is how any resources that support conditional parameters can be discovered. And the way forward was to introduce this IF attribute with the value core.conditional. I think it's still at the moment tentative. Of course, we can change that if necessary. And it's said that the resource may advertise support using core.conditional as a target attribute. So you could combine it with other attributes like so. Also, the resource may support this without really advertising the interface type. And conversely, there is no strictly bound condition that enforces that if the interface type has been advertised, then there's no guarantee that a specific kind of a conditional parameter is supported. So the granularity is not that fine grained for this. Okay, that's a change. So that's a new section. If you haven't had time to read the draft, please go ahead and read it. And then the other part of this was something that I think it was, there was also another discussion around it related to the discovery of these conditional parameters. And I think what happens if you get, if an origin server obtains an observe request that contains a conditional parameter that does not support. So the current guidance in the draft under server processing is that if such a condition occurs, then it should be treated as having no effect on the observation. But that doesn't necessarily mean that you reject the entire request. So the context I got from the discussions is that this is what we want, but I just want to confirm at this meeting that this is exactly what we want, and I've got some examples to show what's now in the draft. So we could have a quick look at it. So essentially what we're saying is that there are two examples here. If you are doing an observation and you have a query parameter such as this that has no real support, what really happens? So you're not going to reject the entire request, but the server will process the request in such a way that it will process it as a regular observe. It will process it with the understanding that, okay, I don't have support for conditional parameter c.new thing, which means that you're just going to get a resource update each time the resource representation changes. Similarly, in example 2, if you have a, let's say, slightly more complex string with a bunch of query parameters, and then you do have support for some and you don't have support for the others, then you go ahead and support the ones that you actually know. So it's sort of treated as a no-op, but my impression is that this is what we want, but we're good to change that if necessary. Okay, so this is basically the biggest changes in the draft, which means that I removed some bodies of text that said we're not going to support any sort of interface formats and so on. So that's just a bunch of text that's taken away from the, I think it was the server or the implementation consideration section. And then the last part is that it has already been, as Marco mentioned, it's already in the post-working group last call. We received early review from the IoT director already, documents ready to move forward. And that's it. That's what I'm looking at. So I'd be happy to take any questions, either today in the mailing list.
Any questions, comments today? Yeah, I just have minor editorial needs that I suggested you offline, and I can make a small PR later around the shepherding process, but it's really needs, nothing substantial.
Sure, thanks. Yeah.
And we have a shepherd appointed.
So I'll do the shepherding. Like maybe one question: do we do another submission before the shepherding for instance, for the title and other minor needs? No?
Not because of my needs. I can make a PR to factor in to prepare a final version to send to the ISG, and that we can work on that together with your comments for the shepherd review.
Whatever you prefer. Yeah, thank you.
So the title is fine. The draft name is wrong, but changing the draft name is
Yes.
Always traumatical, and we should not do that.
So we can proceed with the shepherd up, I think.
Yes.
Okay, awesome.
Okay,
Thank you, Bill.
that's it. Thank you very much.
Thank you. And these slides are not ordered now, so I need to take the long route. No.
Reload them?
They ended up in the end. Let me give you control. There you go.
Right, thank you. So hello everyone. I would like to present some updates to this draft, key update for OSCORE, also known as Kudos. And just to recap, I think many people know what this is about, but it's basically a lightweight key update functionality for OS Core, where you want to renew the master secret and master salt to derive new sender and recipient keys. It has a lot of beneficial properties, and it's flexible in terms of message flow, so that really any co-op message, any OSCORE message can be a Kudos message. It's loosely inspired by the Appendix B2 key update functionality in the OSCORE RFC, but with multiple improvements. But fundamentally, it relies on exchange of two nonces, N1 and N2, and these are placed in a new field in an extended version of the OSCORE co-op option. You then feed these two nonces plus X byte that encodes the length of the nonces and some flag bits for various functionality. You feed that to this update CTX function, which essentially produces a new master secret, a new master salt. We have some features of Kudos, like preserving observations. We also have two modes, one forward secrecy mode and one no forward secrecy mode. The reason we have this no forward secrecy mode is to support very constrained devices that cannot store to persistent memory. And usually, if everything goes right, Kudos will finish in a single round trip. We have basically a state machine. That's the way that Kudos is described. So you have these three states, idle, busy, and pending. And when you start Kudos, you go into the busy state. And then depending on your own state and also the messages you receive, you will progress in the state machine. And if you want to see, here is basically the state machine. And normally you would have a quite straightforward path to this state machine, going from the pre-idle to busy, and then back to pre-idle when Kudos is finished. But basically because messages may be lost or reboots may happen, there are also some more complicated paths that you may take through the state machine. But the fundamental key thing is that you will end up finishing going through the whole state machine, and either you establish new master secret and master salt, or kudos fundamentally fails and you revert back to your old context to continue using it. So yeah, what are the updates we did now for version 14? Number one, we removed a section describing a Yang model for chic, which turned out to be redundant. And this was also related to a comment to another draft where the same change was applied, basically saying that, there's no need or it's even inappropriate to put this Yang model in this document. We did a number of editorial improvements, update to the legal boilerplate and other metadata. And the key thing that I want to focus on is that we added a section now, implementation status, covering 2 working implementations, one in C and one in Java. And we also had a chance to do interop testing of these during the hackathon. So what are these 2 implementations? When implementation number 1 is from us, RISE, basically implementing kudos in Californium in Java, building on an existing implementation of OS Core that we had. And then we have the other implementation from people at University of Murcia, specifically Francisco Lopez Gomez and some of his colleagues. So very big thank you to them for implementing this and offering to interop. And this was actually built in C based on this UOS Core UADOC library. That's an existing library. So what happened during the hackathon? Well, we managed to do interop testing of these implementations. So starting with the Java client and C kudos server, we did a successful execution of kudos in the forward secrecy mode, confirming that we end up establishing the new master secret and master salt that are equivalent, which in turn means we get the same sender and recipient key. Now, we did try 2 consecutive executions, and we did have a problem here because the new OS Core security context derived did not have its replay window reset to being empty or uninitialized, meaning that when we ran the second kudos execution, we had this replay detected error, which is functionality from OS Core basically. But I think this is a minor thing and it can easily be fixed if we have more time to work on it. Then we also tried the Java server towards the C kudos client. And again, we successfully executed kudos in the forward secrecy mode, a single execution. So those are the results, I think very successful. And then we also had some lessons learned. So for the specification clarity, one point that came up was it's actually a bit ambiguous to say that you sort some data or byte arrays in lexicographical ordering, because that can mean like you always take the shortest one first, but it could also mean like in a dictionary that you actually compare the bits straight up, right? So there's a better word, this short lex order, that's more specific, and that's the term we should use. That's the term we intend to start by comparing the length. Only after that you compare bit by bit if the length is equal. Another kind of nuance that we noticed is that because we inherit this structure from TLS that we feed to produce this kudos expand label, and some of these fields basically are vectors, variable length vectors, so opaque data. But if you carefully read the TLS RFC, you will see that actually this vector data type is defined such that you need to prefix the value with the length, which was something that we actually missed. Another thing to clarify is that we say in the draft, like, okay, the empty zebra byte string is indicated as 0x, but just to note that, like, okay, it's actually encoded as 0x40 for the purpose of, bit comparisons. Other points about the key and context derivation: when you derive a new OS Core security context, you should derive a new sender key, recipient key, but very importantly, also the common IV. So we can stress this. We're basically pointing to the normal OS Core context derivation, but this is good to point out. And also to point out that this new context, it should be like, if it's a brand new context, you start over from sender sequence number 0 and you have an empty replay window, which is fine because you have brand new keys, so it's not a security problem. Another point we noticed, that was kind of nuanced more about OS Core itself, but when you do the construction of the AED nonce, you should use the sender KID length even if that KID is not present in the OSCORE option of the message, but you still can retrieve that from the OSCORE security context. Yeah, so to summarize, I think the design is in a very stable state. We didn't do any major modifications in a number of versions, and we have no major modifications planned. So we would like as authors to request a working group last call for this document. As far as implementations, I mentioned we have 2 working ones, Interrupt, and we also have a third one actually kind of work in progress for Contiki NG in C, which needs to be updated still to be aligned with the latest functionality. And yeah, that concludes my presentation. Any comments, questions, or reviews are welcome.
Yeah, I'm not sure when you talked about the interrupt tests that happened here. It's good that we have these interrupt tests. Are we done? Are we happy? Do we want to do any more?
Yeah, very good point. I mean, yes, we want to do more. And I talked to Francisco. He said we can really do interrupt at any point because, I mean, we don't have to sit together in the same room. I mean, we have the internet, right? So, yeah, and specifically what we would like to do is multiple consecutive executions and see that it works. We would like to have that done also, yes. Now, it was a minor thing to fix, but I think that would be good to do.
Okay, so would it be useful to maybe fix a date and say in September where we don't sit in the same room but do communicate synchronously?
I think it makes sense. We can set a date in September. I can run that update, new interrupt with updated code. Just confirm that we can do the multiple executions, and then we can have more kind of strength behind this interrupt to say that it's more like fully featured interrupt, let's say.
Okay.
Yeah, Christian just had a note in the chat that he has editorial comments, but will come on the list.
Okay, thank you. That sounds excellent.
Thanks.
Sure.
Now I have to juggle a bit.
The number of clicks you need to do to get the slide set uploaded or active reminds me that when I joined University of Bremen, I needed 18 signatures to get a student employed. And this has been designed by the same people, apparently.
Okay, hello everyone. This is an update on the co-op multicast responses document, now in version 15. To recap the overall idea, this is an extension to observe defining 7641, introducing observes notifications as responses sent over multicast. It's useful in a scenario where you have multiple clients all observing the same resource at the same server, and it would be preferable that the server notifies all of them at once with a single response sent over multicast. And the idea is that as a new client comes, it attempts a traditional observation request, and the server technically rejects it with an error response offering something better, which is instructions to for the client to align itself and get ready to receive the multicast notifications. The alignment is, first of all, in terms of transport, having all the clients on the same page in terms of token value used for all the multicast notifications, all bound to a same request, which is in fact a cosmetic request that the server produces, sends to himself, and provides to all the client. If you use Group OSCORE for security, there's also a security binding between all the multicast notifications and that cosmetic response using the same traditional mechanisms we already have from OSCORE and Group OSCORE in the external EAD. Okay, what happened since November, actually, last time it was presented, we produced 2 new versions, one in April right after Shenzhen, where it was not presented, and one more before this cutoff deadline. I'm going to overview those updates. In parallel, there were minor updates made also on the companion document describing how this is used in setups with proxies that, if you remember, was part of this document, and it was stripped out just to not overload this document too much. Yeah, but focusing on this document and the first update that happened in April for from version 13 to 14, other than minor editorial clarifications, we made it super clear, like it is in other documents related to Oscar, that the conventional way today to identify an HKDF algorithm is actually identifying the HMAC algorithm on which the former is based. Then we have had for a very long time an Appendix D describing how this can be used in an optimized way together with the deterministic requests defined in another document, cacheable all-score. That has a number of advantages. Yeah, we re-edited that part a bit to describe a bit better what is expected, fundamentally support for that method, and what the advantages are, especially for the clients in terms of a bit less overhead and a bit less operations to perform. And essentially in a setup where such a support is ready and the server is able to support anything like this, well, the server is encouraged to use this method, building on cacheable all-score, but otherwise it remains a side optional thing. More on that same update. I try to be a bit clear on what is required from the client and the server side to do in terms of roles in the group if group all-score is used. And the server really needs to be both requester and responder, at least if more groups are defined in the future. The client can really be anything, and things will work either way, unless, of course, the client wants to send the original observation request with group all-score already. And well, in that case, it has to be at least requester, but inevitable. The update in section 8.1 was a very good suggestion from Christian about generalizing the semantics of an option that we were defining in the interest of this document to enable the rough counting of still interested clients. The semantics was generalized and the name was shortened just to mean the option as a nudge to the recipient of that message with that option to come back with another message for whatever reason, because they wouldn't happen otherwise without this nudge. So that's more general now, but in this document we are keeping using it the original intended way. So for the sake of triggering a feedback, for the sake of the rough counting of still active clients. On the second update made in July and beyond editorial fixes, there were some CDL notations that were not valid and that I fixed. And in section 9.2.1 describing the protection of the phantom request, yeah, it was really precise and say you use group all-score in the group mode, yeah, with the exception that if you use that particular optimization for cacheable all-score, it's not the group mode that is used, it's the pairwise mode, at least it's highlighted now. This was a bigger update that was floating as remnant of notes of all sessions that Christian left as post-meeting actions, I think. What you see here in the figure is the payload of the error informative response sent to clients. We have had that field last notif all along, in principle optional, and still is. It's the field where the server can include the latest sent multicast notification. So of course it's still there and it's still optional. It should be included now, and that's just in the interest of making the latest notification available as soon as possible to the client at the time where the error response is sent already. And this importance, I believe, grows even more if there are proxies deployed in between the client and the server. And related to that, I added also some more text about the age of the multicast notifications. If they're actually sent on the wire, well, that's just fine. Their age is what is indicated by the max age option, or 60 seconds, which is the default, if the option is not present. But if the multicast notification is taken from that field of that error response, well, that age, as it is indicated there, is less reliable because It's a relative time from the moment when the server produced that multicast notification, not from the time when it sent the error response. So trying to amortize this dissonance, we introduced here that the server must compose and send a new multicast notification when, from its local point of view, the latest one has reached its max age. And for the client, we just added consideration about how to read the age indication in anything present in last notif. And still on that same payload, this was another floating suggestion from Christian about making the first field, the TP info, optional. For a long while, it has only been the only mandatory field. Now it's formally optional as to the CDDL, and the text says, well, it may be omitted in some particular setups where somehow the clients already know the transport-related information, and the server is sure that that is the case. And we actually have examples in the companion document. Well, that can be the case in deployments with a reverse proxy. Similarly, getting into the TP info subfield, TPI details, that may also be omitted in the particular case where co-op is transported over UDP and IP multicast. But this is all in the interest of special setups and the formal semantics. Otherwise, like we do in this document, in the normal case, that information is expected to be included and must be included. Okay, finally, we also added a section 13, operational considerations, describing usual suspect contents, like what the server is expected to log locally according to events that happen there, the management and distribution of key material, and how it is possible to enforce access control. Yeah, I can report an implementation that happened at RISE, but in practice, thanks to the great work of a master student, Adrian Castrati, it's for Eclipse Californium. It was tested with up to 3 clients and 1 server. It worked fine. It was tested without security at all, or with security, meaning OSCOR was used for the original observe request and corresponding error response, and then group OSCOR was used to protect the phantom request and to protect the multicast notifications on the wire. Yeah, we believe all the content we have in mind is here in the document now, revisited quite sometimes and stable in its core for a while. So we believe this can be considered for working group Pascal, and just pointing out there are normative references as internet drafts, but 4 are with the RFC editor. The other one is EDN literals that we are using for the CRI notation. And of course, a flag is raised because the data tracker says it's informational, while it's intended to be standard struct, but it's not meant to be a downref. It will sort itself out. Yeah, that's all I have. Thank you.
So right now we have one implementation and that interoperates with itself.
Very well. Yeah, and it took some time to make that one, even if it was in Java that facilitates prototyping and so on. Sure, there's AI today and such. I don't think something like that can be done quickly. It was quite some work.
So what is the best way to actually recruit more implementations? It must be somebody who cares about multicast.
Honestly, my best hope is Christian. Recruiting in general can be not simple.
So we got a thumbs up there. That sounds good. Okay, so the next step there is actually to gain experience through implementation, and then we are ready for working with Pascal, I think.
So working with Pascal waits.
I would think we want one more round of implementation testing.
Thank you.
Okay, Marco just gave an example of the kind of thing I was going to talk about next. The basic idea in CoAP, of course, is that there is a client and that sends a request, and then the server sends a response to that client. And that would be a traditional response. And it turns out we have quite a few non-traditional responses out there right now. So it was time after 10 years or 13 years now to look back and see what have we be do, what did we do that maybe requires some raking in again and finding commonality and so on. So a while ago, I started writing this correspondences thing, and then Christian helped me with that. So basically, we have multicast requests as one case. Marco has talked about multicast responses. We have observation requests. We have an RFC that explains how to not send a response at all. And we have the queue block mechanism that just sends you multiple responses at once. And these are all counted as non-traditional because they don't fit the original pattern, which was one client sends one request to server that sends back one response, and we're done. And of course, there are implications of having these non-traditional responses. For instance, the request might stay active for a short while or even for a long while, and so on. So there may be some common code between these various ways of doing non-traditional responses. So that's why we started writing that thing. So yes, a non-traditional response is one that is not the single response one that is generated for a request received on the same transport. A non-matching response is a response that you get, but that actually doesn't match. So multicast requests don't get replies to the multicast address. That would be weird, but get sent to the original sender. And we have two ways to handle a request in this situation. One is a configured request. That is a request that is given to the server in some other way than in a normal response, in a traditional response. And that might even be configuration. So a device is configured. When you switch it on, it starts sending responses somewhere. That's why we talk about configured requests. But all cases where what the server gets is not simply request coming in over the network is a configured request. And orthogonal to that, we have embedded requests where the server actually writes the request that can also be called a phantom request into the response because a response that has no request associated with it is a little bit difficult to process. So you either know from configuration what that response is for, or you maybe embed the request into the response. Luckily, we have the OSCORE format for embedding one thing in one other thing. So we don't have to invent a lot to do that. So that's the landscape that is opened here. The draft has, besides this general discussion, a number of options being proposed. And for a while, we weren't so sure what to do with these options. So response 4 is an option that can carry an embedded request. So this says, here's my response. And by the way, this response is for the request given in this option. So the receiving client has an idea of how to process this. And as I said, we have the OSCOR format for requests and can use that. So this is a response option, and on the request side, we have the leisure for responses, which is one way for a client to indicate readiness to receive multiple responses. We have other ways, of course. For instance, qBlock has ways for a client to say that. But this is intended as a general way to do this. And we also, I would almost say, hallucinated about an option respond to, because that is your typical three-legged situation where A asks B to respond to C. And we know that has some security implications if you don't do this in a very controlled, very safe manner. So to actually complete the description of this option, we would need to explain under what situations it is safe. And really, there are so many different contexts, so many different situations you might want to do this, that it's probably a better idea to have options for the specific cases that we know we can make safe. So this has been known for a while, maybe not aggressively discussed on the mailing list because it was kind of common knowledge. But that of course has the disadvantage if we don't get discussion, we don't get progress. And maybe we should now learn from what was on the previous slide and distinguish between those CoAP options that actually would make sense today and those that we have to develop further. So the current draft proposes to go ahead with leisure for responses and response for, and to put the respond to on the back burner, describe its general characteristics so that specific drafts can pick this up if they can make use of it. But it's not something that we standardize now because yeah, to do this in a general way is a problem that is not yet solved. So yeah, my last question, or my questions slide, questions to the working group, is that a reasonable perception? Are we ready to go forward with response for and leisure responses, leisure for responses? Is that something we want to have as part of the toolkit, as part of the options that are defined for CoAP? Very well knowing that leisure for responses only has one way to put a limit on there, so we may want to define variants of that. So leisure for responses counts responses. It says, send me up to 5 more, but maybe I want to say something like, I'm going to listen for 5 seconds for more responses, and then I'm off the radio again. So that those things are conceivable, but it will be very easy to model them after the one that is in this draft. And conversely, on the respond to, we put this in the back burner. And there are 2 ways to do this. Just strike out all text or keep the discussion in an appendix. We opted for keeping it in an appendix at the moment because it's just good for someone who does need to define a respond to option. So that would be the proposal to go forward. Of course, then again, we have the question, who has implemented that? So it's not going to be completed next week, but that might be a reasonable way forward. Any comments on that?
I have a comment on leisure for responses. We already have a specialized version of it, if you want, in the group com proxy document. Mm-hmm. There's a multicast timeout option for requests that is serving 2 purposes, saying, first of all, I'm happy to receive multiple responses, and for how long, and that's intended to be consumed by a proxy though. Still, it's kind of aligned There's a partial overlapping. So I don't know if in your general blueprint you had in mind to cover the two, or it diverges enough to be really something different to be rechecked.
Well, we could simply point to this and explain that's the other way of doing it, not using a number but a time.
That's good.
That's good, Ike, joining in. So I was thinking while you said that we could rename our option to make it more general, and then instead of saying multicast leisure, just calling it maybe leisure for responses or something.
Yeah, leisure is actually something you would associate with time and not with numbers. So it's maybe a better name for your option, and we call this one something else.
I was coming to that. Yeah, there we really measure time, and then as many responses come, whatever.
Yeah, the difference is indeed time versus measuring something else, right? So the number of expected responses, and in our case, it was really time. So
yeah.
But we could still generalize that, like that you can think of even without going through a proxy or multicast, that you could just say, well, send a request and put a leisure option in, and then expect responses to come within that time, for example. But although I don't think we have defined what actually it means for a unicast request to have like 2 answers, for example, from the same server. I don't think we have semantics for that currently, but well, once we have the option, we could start thinking about that.
Leisure for multicast leisure for responses.
Okay, but that's an idea to do something with the naming and to make it prepared for the generic case also.
Christian, I'm just, I think that option makes sense for unicast, and it will just require an option to make the precise responses non-matching. We have in Onion or Score, actually in Onion Co-op, options prepared that are basically around something like I'm sending you that message, but like the host name that this is really about is this and that. And I think that slots in nicely here, because if you were using that multicast proxy and you're taking multiple proxy hops, it's even in there. It's like there has to be an option that ambiguates where that response is coming from, and that can work with unicast just as well as with multicast. So I think we should generalize, and we already have the options that make use of that.
So it's just about finding a better name.
So Christian is a co-author, so that will be easy to do.
Yeah.
So I know how we go forward.
Thank you. So next is Wojtek, not you, right?
Yeah, okay, let me say one sentence while Wojtek is coming up. So the next section is the usual CoreConf section. We discussed this, and Wojtek thought it would be a good idea to just talk about COMI today. We have 2 other documents that we need to work on. One is the Yang library document, which is kind of interesting because in the Yang world, the Yang library has gotten a lot of fresh discussion, and we need to find out which of that is actually applicable to us and which part we can ignore. And what was the other document? Metadata, which is essentially a slam dunk, but right now it's just waiting for someone to implement it. And so if you are interested in Yang metadata, who in this room knows what Yang metadata are? I do. Med knows. Not bad. 5 people is probably a higher concentration than you can find in many other pieces of the planet. Okay, so these are not the subject, but we're looking at COMI.
So let's focus on the COMI. Short introduction. The NetMod working group produced Yang, which is modeling language for configuration, status data, and similar things. And they have protocols such as netconf and resconf for accessing the configuration and changing it. And so we want to bring CoreConf for the constrained environments. In a Yang word, they define data store, which is like copy of the configuration, and it may be in several instances. Like the whole configuration can be So the data store is basically a storage for the configuration, and we can have multiple data stores to describe different configuration for different states. The architecture is pretty complex, so the CoreConf just specifies one data store to make it simpler. And I think the specification is not clear and it is not complete for the unified data store of the CoreConf protocol. This is citation from the draft. This is table required to describe the data store. And this is example of a CoreConf message. Here I want to emphasize the format content type, which is not CBOR, but CBOR sequence. And the items in the sequence is always a CBOR map. And about the semantics. The CoreConf protocol is designed as a similar protocol as RESTconf, and the RESTconf protocol is utilizing the RESTful design. And the RESTful design comes on that the message is a transaction, and the transaction is performed automatically. But I am not sure if this design is good for the constrained environments because implementation of the transactions is resource heavy. We also messages of the CoreConf protocol is richer than the messages of the RESTconf protocol, and this brings this creates the problem even harder because we are not talking about one subtree, we are possibly talking about transaction consisting of several subtrees of the data store. So my proposition is that the request is not processed as transaction, and we are processing the things in the message one by one. And I suggest these solutions. The first one is just simple. The transaction has several. The message, the request has several CBOR maps, and we process them one by one. If something fails, we don't care. We just continue processing. The made before break semantics creates a group when we are also processing the things in the request one by one, but when we happen to encounter a problem, we just skip all the remaining parts of the group. I would propose that we encode the group as a CBOR map. This way we don't, so I think the CBOR sequence is used to make it easier to stream the data in the packet, but we can imagine it as being an implicit map of the an implicit array of the maps, which is the tasks done in the request. Yes, this is last. So I want to open the discussion. What do you think? And ask the working group for comments.
Christian Amses, I have very little to actually none experience with Yang, but with implementing co-op servers and CBOR, having that list sounds very reasonable, especially because the sender will know the length of like what they want to have done in a make before break fashion, and then can still retain the options to stream the rest. So kind of looks good from that perspective.
Esk, are you also in the queue?
No.
Oh, okay.
Yeah, Customer One, I just wanted to give a little bit of historical context how we got into the situation we are in. So COMA is a pretty old document. So I think we started this in 2013. Took us a while to understand that we wanted to have SIDS. But parallel to that, it was pretty clear how to use Yang to the people involved. But then the netmod, netconf people came up with NMDA, which is the new data store architecture or something like that. Thank you. And we actively ignored that. And at some point, a reviewer from the Yang community asked us, what do you do about NMDA? And yeah, we said, no idea. Because none of the experiments that people were running really seemed to need that. So Michel went ahead and wrote a section that explained, oh, we have a unified data store and we can do things. And yeah, but that's not the reality that we find in the CoreConf implementations today. And so this is essentially an attempt to create a low overhead solution to the problems that we actually might have. And the biggest one is the make before break problem, that if you have a number of configuration steps where one step needs to succeed or the next step will disconnect you from the network, it makes sense to group them like Wojtek described here.
Thank you.
Skodak, just a question. If one of the multiple items fails, I think you proposed then we can skip it. So is there a feedback then back to the client? So what succeeded, for example, and what not?
How the response is structured is not yet decided.
Okay,
So
to do.
I imagine that you fill in the things that you can do, and the things where you have an error, you just put none and some kind of tag to describe the reason of the error.
Okay, yeah, that sounds good. At least to have the feedback clear in that case. Thanks.
Looking at the CoAP toolkit, we have two things that we would pull out. And one is RFC 8710, which tells you how to send back multiple responses to something. So that might be useful. Yeah, we can use the how do we call that, problem details mechanism that we have copied from the HTTP world. Instead, in COMA, we invented a Yang-based variant of the problem details mechanism, which already has received some not so happy comments, because you probably need problem details anyway in a server that is on the internet. So we now have two different ways of doing this. So that's maybe some place where we could say, okay, we could take the big hatchet and throw out part of the document, because we now have new stuff we can use.
Thank you very much for the presentation. So Karsten mentioned that we've been working on this draft for 13 years now. I'm just wondering, can't we try to ship it is a simple way and then have another document that says, well, actually doing transactions and MNDA, all that, this is how you do it. So here we have a very simple command for super simple devices, and if you do transactions like that, do the other thing.
No, but basically this is the point. I want to strip the current wording. I want to strip out the semantics of transactions, because if you look at the text, the patch fails whenever there is an error, and you should roll back to the state before the patch, which we don't want. And so we propose these two simple solutions: no dependencies whatsoever, and dependencies as in a group. And we then fix the atomicity of the processing of the one request in later document.
Yeah, so the atomicity would be an extension that we can think about for some more time, but we do the simple thing first.
Ivailo Petrov. So do I understand correctly that now with this thing we can get into inconsistent state, but we trust people will be careful how they develop their models so they don't do that while we fix things?
Basically, yes, but I think that the server should not care, and the client should create the message so that it shouldn't create inconsistencies. Or if it does, it should repair it by the contents of the response to the request.
Okay, just a small addition, Eskodijk. If you don't want to apply the patch semantics, then you could also say we're going to use a post now, and a future document will define a proper patch or something like that. That's also an option.
I think that this is the patch. Like, you have several things you want either delete, create, or edit. And if you are sending a post, it is connected to the young RPCs and young actions, which is a type of RPC. So the post is already used for something else.
Okay, yeah, that's already taken then, yeah. No, just to avoid having a patch now and then needing in the future a second patch with another semantics, that would maybe not be so nice. So
I think that you should decode the semantics of the patch from the options in the message, in the request.
Yeah. Okay. Thanks.
I want to also respond to the Christian comment that the map may be indefinite. So you are not aware of how many things there are. Anything else? So thank you very much.
Thank you, Wojtek. Okay, next should be Ricardo. There you go.
Right, thank you. Yeah, I would like to present some updates to this draft, OSCreor capable proxies. So what is the scope and content of this document? Well, we're updating RFC 8613, which is the OSCAR RFC, and also 8768, which is the hop limit option RFC. So basically, we're defining the use of OSCAR in a communication leg, including a proxy. So this means that you can have OSCAR between an origin client or server and a proxy, or between two proxies in a chain. So basically, you make the proxy like an OSCAR speaking node, which is something new. And we also are defining rules for the escalation of protection of co-op options. So this means that if possible, you should encrypt and integrity protect an option, even if it was originally classified as class U for OS core. And the point here is that we want to protect the options as much as possible. And when proxies are involved, as OS core speaking nodes, you can actually protect more options, such as the proxy URI option can be protected for the proxy. We are also explicitly admitting the nested protection of OS core messages, which is needed for this solution. So you may have an end-to-end protection between the client and the server. Then you have one more layer of OS core protection between the client and proxy. I mean, typically you would have at most 2 OS core layers for the same message, one end-to-end and one between 2 adjacent hops. But you can have more layers as you wish. And this is also something new that OS core currently does not support. On the hop limit option, we're defining that to be class U for OS core just because there was no class defined for it. And I mean, the focus here is OS core, but all the same logic applies also to group OS core. So update since version 6. This mostly about 2 points from Christian Amsis, his review of version 4. So thank you to him. Other points were already addressed. And we have also a detailed reply on the core mailing list. But the 2 points are about section 2.4, processing of an incoming request, where we have improved significantly the presentation of the algorithm on how to handle incoming requests. And we also have content now about guidelines for a proxy adjacent to the origin server about when it should try to establish or use OS core with the origin server. So for the processing of an incoming request, this was a major revision of this algorithm, but only the presentation of the algorithm. The actual logic and the outcome of the algorithm has not changed. It's just presenting it in a better way. And we also did a check to make sure that the functionality has not changed by checking the state diagram in Appendix D and seeing that this change has no impact. It's just explaining things in a better way, in a clearer way. And if you want to see the gist, there's a number of points here, but basically I would recommend checking this in the draft to get a full picture of how it works. So another point was about guidance to the proxy. This is a brand new section 5.1. So the question is, when should the proxy use OS core with the origin server? How would it know? For DTLS, you can have co-op S, but for OS core, how would it know? So there's 3 questions here for the proxy. Number 1, does the server want to use OS core between itself and an adjacent proxy? And here you could actually rely on an SVC param key within a SVCB resource record about the server. Second question, does the server support use of the multiple nested layers of OS core, which it may or may not do? And again, you could rely on an SVC param key to discover information about this. And the third question is, does the server support the key exchange protocol ad hoc? And to discover this, you can rely on the functionality defined in the app profiles draft. And how to answer these questions 0, that comes from how you answer these questions 1, 2, and 3. But one open question here is, should we actually define and register 2 SV param keys as mentioned above? That would basically be for discovering support of nested OS core and discovering the desire for the server to use OS core between itself and an adjacent proxy. So just to show a illustration or figure of this. So if you see basically top left, you have the question 1, does S wish to use OS core between itself and an adjacent proxy? Yes or no? Question 2, does S support use of multiple nested OS core layers? And then question 3, does S support the key exchange protocol ad hoc? And for question 3, there's a way to discover this. Question 1 and 2, that would be about this SVC param key. And we also have in the draft now a new example of a message exchange in Appendix B6, where we are showing an example with 2 forward proxies in a chain. So you have the client, proxy 1, proxy 2, and then the server. We're assuming all OSCORE contexts are in place. Obviously, you could use something like eddoc to establish these. And then we actually have OSCORE between the client and server, between client and proxy 1, between proxy 1 and proxy 2, and then also between proxy 2 and the server. Just to show a bit more, let's say, advanced example of what you can do with this. And if you want to see the details, I would recommend checking the figure in the draft. Yeah, and also the report on some implementations. We actually have 2 implementations of this. One from a master thesis student called Lucas All. He implemented it in Californium in Java. So we tested this with the URI proxy option and also the proxy schema option. Tested with OSCORE over client proxy and client server and proxy server. And we also tested using observe and establishing the context using eddoc. Then we have another implementation from Manasassan and Wong Prai for Contiki in C. And here we have tested on constrained Solarity of Firefly nodes, only testing with the URI proxy option and testing OSCORE between client proxy and client server. And by the way, we also have interop these 2 implementations towards each other. So what are the next steps? Well, we want to handle a replay and local ordering of multiple responses to the same request. So this is basically the same rationale that we have in group OSCORE. So you can have a scenario where you have a single request, but you actually have multiple responses coming to that request. And then it's important to not allow replays and to maintain the correct ordering of these multiple responses. We also want to add operational considerations section, and depending on what comment review we get, possible other things. So yeah, thank you. That's the presentation.
Yeah, I have a question related to the next steps. It's best if you show slide 5, actually.
Mm-hmm. Slide 5. So
yeah, right, the red text, basically. Right. So yes. Christian suggested to consider the SVCP param keys as a way to learn about that. And right now we had the text mentioning that that's possible. But yeah, we take that seriously. A next step can be also actually defining those keys and registering those. Any opinion about that?
Yeah, any feedback on that is very welcome. And again, the point here would be, let's say, service discovery, to discover that a server supports a nested OSCORE, or to discover that the server wants to use OSCORE within itself and an adjacent proxy. Which may be, like I mentioned, for DTLS, you can have the co-op S in the schema, but for OSCORE, there's no like equivalent way to indicate that. So this can be a suitable solution. So feel free to comment on that now or on the list later.
It was a good suggestion, so we can give it a try. And at worst, it may remain just a suggestion of a way to do that, but they should be pretty simple keys to define compared to other ones we define in other documents. Okay, any more comments or questions, anyone? Okay, thank you. Okay, hello again. This is a brand new document that is also related to a document I presented in the ACE working group on Monday. It's about group OSCORE and it's about post-quantum. Yeah, we completed the work on the group OSCORE document. Now it's with the RFC editor as the security protocol to protect group communication for co-op. And yeah, I started to wonder, group OSCORE is quantum resistant or ready for post-quantum computer. Group OSCORE has 2 mode of operations that you can choose on a per message basis to protect the messages. The group mode should actually be fine because it involves symmetric encryption, decryption, and signatures from the message sender. And well, as long as you use a quantum resistant signature algorithm like MLDSA, you should be fine about that. And the different variants of MLDSA are registered in the COSI algorithms registry already. The pairwise mode is a different thing. It doesn't have signatures. It's purely symmetric encryption decryption with pairwise keys established between the two exact group members. The catch is that those keys are established through a pairwise key agreement algorithm that right now is only Diffie-Hellman, that is not quantum resistant, and at the moment there are no equivalent drop-in that you can jump into, and there are no standardized equivalent DH90 that are quantum resistant. So this draft is proposing a way to make the pairwise mode quantum resistant, not really changing the pairwise mode in itself, but focusing on a simple variation of the derivation step where the pairwise keys are derived. So still based on a key agreement algorithm, but not through Diffie-Hellman, but through a post-quantum chem, for example, MLChem. And the different variants of MLChem are in fact intended to be registered in the COSI algorithms by a document in HOSI, in the HOSI working group. But again, it's about the derivation of the pairwise keys that then are supposed to be used as is, so there is no change whatsoever in the pairwise mode as to the message protection and processing. The nice thing is that GroupOSCO relies on a group manager entity that, among other things, is already responsible for collecting and distributing the public authentication credentials and public keys of the group members. So we can build on the same advantage and concept that have the group manager responsible also for collecting and distributing information such as the CHEM public keys and the CHEM ciphertexts that the group members will need to exchange in pairs to establish the secrets in this new way instead of with Diffie-Hellman. And as we already do for other services provided by the group manager, details don't really belong to this document. We just need to outline the blueprint of what we need from the group manager, and the how can be left for totally different documents that describe a specific realization of group manager. Yeah, on the main thing to really define the derivation of the pairwise keys, here you can see compared on top the old current way with Diffie-Hellman, and on the bottom the new way. And I highlighted in green what is kept as is, and it's almost everything essentially: HKDF, info, sender recipient key, sender and recipient authentication credential, and again the use of the pairwise keys that follow. The only thing that changed is a component of the IKM sender-recipient parameter that is not anymore a shared secret produced out of Diffie-Hellman, but a sender shared secret or a recipient shared secret established with a CHEM. And that's it. So, of course, if you assume that you have exchanged through the group manager the CHEM public keys and the CHEM ciphertext, and you can produce the respective share secret, you plug that in, and everything that follows is as it is already today. Looking at this from the perspective of, say, this endpoint that wants to be sender of a message and needs to have a sender share secret to produce a pairwise sender key. This endpoint would compute the sender share secret using the CHEM public key of the other endpoint X, and you would encapsulate that secret into a CHEM ciphertext intended to X. And that same secret will be the recipient share secret from the point of view of the X endpoint. This endpoint, again, instead can compute its recipient share secret using its own private key to take away or encapsulate the share secret from the CHEM ciphertext that the other endpoint X computed for this endpoint. And the idea is to use a given CHEM public key to compute only one CHEM ciphertext only for one other endpoint in the group. Again, with the group manager facilitating the exchange of the input information. Speaking of which, and with the idea of giving only a blueprint of operations here, like we did for other operations, section 4 is defining what we need more at a high level for a group manager that supports this. At some point, we need a concrete example, a concrete realization of group manager that does this. And well, we have a realization of group manager based on ACE already. It's also with the RFC editor. And what I presented on in the ACE working group on Monday is a new document that extends that exact group manager and extends its interface to provide also these operations needed here that are surprisingly for uploading a CAM public key, fetching CAM public keys of others, uploading a CAM ciphertext, uploading the CAM ciphertext produced by someone else for me. Only principles here detailed for the specific group manager. Now ACE can build a concrete case. What's still really missing to me is what I left as pretty much TBD in section 3.1, where I would like to give a bit more details and guidelines when the particular CAM use is exactly MLCAM. I think this can largely build on the parlance, the guidance style that I could see about this in the HOSI document registering the COSI algorithms. And I can see that in a similar way, a document in Lake defining the new ad hoc post-quantum cyberspace is also building around. So I plan to take inspiration from there to fill in this section. But besides that, in its main contribution, the document has pretty much what I had in mind. So please, comments, reviews are very welcome. Thank you. Christian and someone else that I don't see.
Christian, just a brief question for clarification. An attack on the elliptic curve cryptography in there would just defeat the source authentication within the group and would reduce the confidentiality from pairwise mode to the group, right? So that's the group secret that is distributed independently is still like protecting the group as a whole, right?
Yes.
Okay, thank you.
Very good point for the security considerations. Thank you.
Hello, Renzo Navas, IMT Atlantic. Thank you, Marco. I'm just to say on the mic, I will gladly review this draft.
Thank you.
Before next IETF. So.
Thanks a lot. Yeah, I don't know if there's anything in the chat. I think the queue is done. Okay, thank you.
So the next speaker is Laurent.
Yes.
Hello, do you hear me?
Yes. Hi, Laurent. Give me just a second to pick up the right slides and give you control. You have control now.
Yes. Okay, thank you. So I wanted to present you a work we have done with Sandosh Balakrishanan from AFNIC and Alex and I from IMT Atlantic. So the goal is to study how we can put seeds into the DNS. And we think it's something very useful because when you receive a CoreConf data, you have to understand it, and the DNS may help to find the information. So just so what we have done until now is so we talk about PyCoreConf and all that stuff. So it means that we can transform a CBOR representation into a JSON1 with ASCII identifier that are very useful. But for doing that, you need the seed file or an extended seed file that contains the type of each leaf. So we think that we can put that on the DNS. And why the DNS? Because it's something that exists and is credible and is used to do this kind of mapping. So what we propose in the draft is a technical way to transform or to store a seed into the DNS. And we will see after that some administrative delegation for the resolution. So we made the experiment in seed.yt. So YT means for us a young tracker, but it's also an island in France that is Mayotte Island that has this prefix. And it should go to the ARPA if it works. Of course, it may be in the ARPA, not IANA part. So the technical principle to store the seed into the DNS is to take the full representation, so with all the zero you have on the left, and then you inverse the notation, and you put points between, and you add the postfix at the beginning, like seed.yt, and then this way you can make a query for this seed on the DNS. So we have, so is what I say. So we have different different range. So the first mega range is managed by the IETF. The other one will be managed by other SDOs or people that request for a mega range. And we have also some places that are for private enterprise number. It means, so if you have SNMP file, you can take a number, an SMP value, you can use it to create your own pen. So just an example here. So I will skip this one. So here is an example of what we can do. So on the top, you have your CBOR structure or CBOR file information that you get in hexadecimal. And of course, you know that it's core-conf, so you can, receiver can start finding the structure, but very quickly he will find a seed and he will not know what to do with it. So what we propose is that once you find a seed you don't know, you query the DNS and you get a pointer to a seed file. So right now the implementation is very, very limited. It means that it's just a pointer where you can upload a file, but it could be a pointer to a young library if needed. And with this information, then you can transform automatically the binary sequence into a JSON sequence with identifiers that can be understood. So one important thing in this transformation is that this serialization may be the result of several young models. For example, we can have a young data model that defines the structures, but the identifier inside may belongs to a company, or you can augment also the model with other things. So that's why it's very important to get all this information to understand the full structure. So on the bottom, you have the DNS query that has been done. So the first one ask for the seed that we want to solve. And what we propose as a structure is that the answer is the entry point of the model. And once you get the entry points of the model, you get information regarding the module. And for example, the seed file, but it can be also a transformation to an ontology, a turtle file, or something else that helps to understand. And then you have the query for getting the files. So looking at the structure, so as we say, IETF may run his web server to his DNS server to manage the files that are the seeds that are on the IETF mega range. Other SDOs can do that. And maybe there is a problem when we look at private enterprise numbers, because these numbers are located from long time ago. And maybe it's very difficult to get when you have an identifier, a name here, maybe it doesn't belong to the company anymore. And so making the link between these two numbers are maybe complex. So pens can be used when you want to use internally a young data model or transform into core-conf. But if you want to publish it outside, it may be difficult. So that's why what we propose is, for example, that registrars can also have their mega range and manage this mega range with their customer that will request some numbers, and registrars will allow to maintain the integrity of the seed files in the model. So that's some open question we have to solve to continue on this work. So do we need really to allocate seed files that doesn't belong to standards like IETF standards? So can we have manufacturers seed files, but maybe are not pens number? How we can guarantee the consistency of the resolution, because when a seed is allocated It cannot be changed. It can just be deprecated. So we'll guarantee these kind of things. And how to secure all the resolution to get this information. For example, can DNS may be used for that? So that's some question we wanted to ask to the group. And we would like after that with Sandosh to go to the DNS groups to discuss about that. So
Maria from Bird and coincidentally from CZNIC, who is running quite a big DNS. I have a bunch of questions regarding using DNS for this. Some of these are like, what's going to happen when the company goes down and the server goes down, because running the DNS takes some money. Then I think that the document definitely needs some IANA actions. Most specifically, there must be a complete procedure how to actually register the DNS sets for every pen. Then one would probably have to make another procedure to checking whether that person who is actually written with the pen as a contact is actually a contact of the company, because there are companies where I am quite sure that that person is not longer ever working for that company. And I could go on and on. So I would like to ask you whether you were thinking about these problems and whether you are expecting to resolve them, because I see them as quite a big roadblock.
Yeah, you're right. It's so if a company goes down, and so what happens? So normally the seed cannot be allocated anymore, but the young data model still exists. That's why maybe a registrar can maintain this allocations. So, and that's something we have to study how the registrar can do that. But when something is allocated, it's for life. So the thing cannot disappear from the internet. And registrar normally are some very stable structures that are here for to last. For IANA action, yes, we have to see, but that's the first version of the draft, and we have to give more details in the following one.
Wojciech Willimek, the RFC 9595, that is the SID files, already talks about how the registry for the SDOs should look like if they request the mega range. So I am asking, is this really needed, or what is the relationship with the already existing definition?
So that's also a good point. So we that's what I said. Right now we have a link to the SID file that is not very very secure in this example. So what maybe one mapping can be between a number and a namespace. So that will be the minimum. And once you have the namespace, you can go to query for the model. But we have to look also at scalability. And if we have the database that is stored only on one place, maybe it could be a problem.
Okay, thank you.
Hello, Christian Amsus. Especially when you consider delegation in there, this might easily create a privacy situation, because all of a sudden a person opening a file can reveal that they're opening the file just by dereferencing the thing that eventually hits someone else's DNS server, where there might be a canary thing in there. Carsten and I have a draft in T2TRG called dereferenceable identifiers that talks about, like, we don't have the solutions either, but it talks about many of the concerns that you have here and adds a few more. So I hope it helps, but it will also raise a few questions that we'd come to either way.
Okay, thank you.
Maria again, sorry, I found out something more. One of those with the delegation and something going down, the registrar would have to be paid for keeping the registry up. And there is like nobody to pay if the company is bankrupt. So the problem, the one problem in this is basically there has to be an infrastructure if we are speaking about DNS, and this is about storing information about some data, about probably some product which has been sold like 10 years ago, 20 years ago. Like if you look into 2070, we are speaking about almost 50 years of manufactured things, and these things may be like long forgotten, companies 15 times bought and dissolved. So I don't see that the delegation is actually gonna work. There may be some central authority, if we ask very politely IANA, that they would register everything for us like they are doing with pens. But I am quite sure that this is much more data that they would actually be willing to store. So my point is basically we should mandate the devices to carry their own SID files inside them. And because if we don't do this, we have just a black box.
Yeah. So just for the last point, if you do that, it means that you have to send the SID files when you send the information, and when you have a sensor, maybe it's not very easy. And the SID by itself is a pointer to the information. Regarding the business model, is something, of course, we have to study, and we work with AFNIC and that. It will be different than the DNS, the names as we use for the DNS. If you don't pay, you lose your name. Here, it's the file has to remain. Yes.
Yes, thank you, Laurent, and thank you, Maria. Just one point actually to all this discussion. So in the SID, in the RFC, actually, it is said that, okay, there are registries, and these registries, they need to be registered with the mega range registrars and so forth and so forth. And the only thing that, it doesn't speak about any type of interface to these mega range registries. So anyone can just say, well, I want to request to become a mega range registrar, and maybe I have some HTTP or HTTPS or any kind of interface. So this draft here just says, well, there is the DNS interface to that, and it's very universally understood. And the problems with that you're mentioning about, like, someone needs to be paying for that infrastructure for eternity, that's a problem for anyone, right? We tried at the time asking IANA very politely to do that for us, and then they very politely said, okay, we'll do that for the RFCs of IETF and nothing more. So I think that there was also some generic questions about how that will run. So just to say that this document is just saying, hey, there is a DNS interface to these registries, and other than that, there is nothing exceptional for the SID registries. But these are exactly the questions that need to be solved by the people that would like to expose these kinds of interfaces, right?
We have a person online, I think. Sandache. We can't hear you. You're muted.
Can you hear me now?
Better now. Thanks.
Yeah. Santosh Balakrishnan from AFNIC, one of the co-authors with Laurent and Alex. So I do agree with the questions raised by Maria. We at AFNIC, we are also hosting the .fr registry, and we have seen such use cases before with RFID and IEEE identifiers. So there are certain things to be narrowed down regarding the business case, but as a registry, we do feel that this is one potential economic viable point for a registry.
Let's go.
Maybe I'm next. Eskodijk. Yeah, I think I probably agree with the previous speakers, Alex and Maya. So the IETF could basically host this for their registered modules or SIDs, I think. But as soon as you go into the mega ranges space or other ranges that are managed by other organizations, then it can be a bit difficult, because one organization might just keep a record on a piece of paper and doesn't do anything else. And the people building like clients and servers for that and devices, they would just basically know what each SID means because it's specified in some document that they have access to. Maybe it's not even a public document. So I think that part is going to be difficult as soon as it moves out of the IETF. So that means you don't have a general solution to look up these SIDs. Maybe for the IETF standardized ones it could work, but not generally, and certainly not for the private ones, because we don't have any requirements for the companies to publish anything about it or expose any interface by design. So it's going to be difficult to make it generally available, I think. And then you get, kind of a solution that covers a part of the whole SID space, and then it might not get used because it's not covering 100%. I was also wondering about the exact use case for this. It's also not fully clear yet from the presentation, but maybe that I should read the draft for that. Thanks.
Okay, yeah. It's the goal is that when you ask for example, you have a fetch and you receive your information, so you have to understand everything, and so you need to get understand all the SID that are included into, and they can come from different spaces.
Could be already built in the software that basically requests the data from the devices, right? So it should be based on some specification that.
For the device, but when the device is so we had a demo at Hackathon where we saw a weather station. So we use a generic representation of the information, and then we had some identifier that were dedicated to some specific measurement. And so when you define the global structure, it can be viewed from IETF. But the manufacturer may add his own sensors, his own counters, and so he has also to publish and say this is this kind of measurement, and so here he needs to publish a SID. We can discuss that.
Thanks.
Thank you. Thanks, Laurent.
Thank you.
And next is Lindsay. Start the dance again. Give me a second to look at the slides.
Thank you. Hello, everyone. This is Lin Zhou from Beijing Zhongguancun Lab at Chinese Research Institution in Chang'an. So this draft is about the COPE extensions for asynchronous task resources. And then the main goal of this draft is to provide a common way to create, control, and monitor the long-running tasks in COPE. So let's start it with the problem statement, why COPE needs a synchronous task contract. COPE request usually returns the immediately result after the application method has been executed, but some operations will continue to run after the request is accepted. For example, the firmware installation, the incident diagnostics, and any other complex tasks. Nowadays, the applications are usually defined by themselves. They define the the job IDs, the state name, and the control method by themselves. So the pattern, we can see that the pattern is common, but the contract is application specific now, so that which makes the client is hard to manage the synchronized task in a common way. Here is the deployment made by NS Focus, a cybersecurity company in China. And in this project, we customize the task list according to requirements for task assignment, and stipulate the task should be executed in sequence. The task execution status is observed using private domain definitions. In this project, we found that by monitoring the task, we can locate the fault quickly, and also we can know the state of every step. It's very useful, but we only can understand this kind of information under the customized definition. So that's why we propose this draft. This document defines a COPE framework for representing asynchronous and long-running operations as addressable task resources. In this draft, we define the lifecycle, including common status and terminal retention, and also the interactions, including creation, observation, and others. And we want to use the call link format to do the task discovery. And also we propose a request model, including the resource content and also the task controls. So in this draft, we also reuse some of the existing mechanism. Here's the task life cycle we define. Firstly, all the task is start with the state pending, and after that we have active the operation, which means the operation is in progress, and obviously we have completed, and there are also some status to describe the incidents, like the failed to complete after the execution started, and we have aborted state. The plan can cancel the task before its completion. And also we have a rejected state. The task resource has been created, but the dynamic approval before execution failed. For example, the memory or the capacity is not enough for the task. The task will go to rejected state. And also the final state task should be kept for a sufficient period of time for the client to read. Here is the task request we define. We use content format 62. We have four parts of payload. The first part is about the resource content format. It register the COPE content format for part 2. And in the part 2, we have the resource representation. This part describes what the task should do, including the target resources, operation order, execute profile, and the others. In the third part, we have the task content format, similar like part 1. And in part 4, we have task representation. This part describes how the task should be executed, including the execution mode and profile specific task parameters. Nowadays, we have right now we have two kinds of execution mode. One is atomic, guaranteeing nothing or all, and another is sequential. It means the task should be executed in order, and it can report the sub results. And here is the workflow for task creation and control. First, the task institutor can make a post request to create a task. Before create, the executor should do some validate, check the operation and the execution control can be supported, and do the authorization. After created, the new task resource URI is returned using location path, and then the client can do the observe, can register and observe relationship on the task resource. Here is the detail of the task status. We have the task state, obviously, and the progress percentage, and estimate seconds to complete, and also the diagnostic text, and also the sub results. Except for the complete one, we also have the lightweight one on the below of this page. Here is the open issues, because it's a new work here, so we welcome feedback. We have some issues here. Is this a useful common abstract for COPE? Are there any other existing deployments or models we should align with, or other existing COPE mechanism that we should use in this draft? And also, are the life cycle status is clear right now? So that's my question, and that's all. Any questions or comments?
Hello, Christian Amsus again, and sorry for being so much on the mic. so the pattern does look familiar. What I'm wondering is like, at what level are you, what level are you describing your tasks? Because some of those things look familiar from things like uploading really concrete firmware items that really like spawn like a process in a real-time operating system, where then the introspection would really be like basically get me a backtrace of where that task is currently pending. So at which levels, like do you envision, or do you use this on like really a level of like uploading assembly, or uploading tasks in a more high level way, where percentage of completion then makes more sense than if it's really binary code, or is this flexible with respect to that?
I think it's for service level.
Sorry, it's for?
Service level. We have some service over the code, and for the service, we can use this task management.
But I'd hope that it could be generalized, but of course, if there are showstoppers, then not. But if sounds to me like this is a useful pattern, especially if it can be generalized.
Maybe we can propose some use case to clarify that.
Yeah, just a quick comment, a procedural comment on this. You see, this is a -01 draft. So you showed us the first version of the draft last week, and we had a lot of comments, and they are all in there, very satisfactorily. So that's really great work. And I also agree that it is a good idea to write this up. I mean, it's not a standard in any way, but it's a good description of what you do when you need this kind of information. The classical case, of course, always was a coffee machine, where you have an action to start making a coffee, and then you want to be able to influence this action because the cup overflows or something like that. And so this seems pretty familiar.
Okay.
Thank you.
Many thanks to, yes, Marco, Jamie's, and Carsten's feedback for this draft, so that we can version 1 here today.
The draft is already considering access control, pointing to ACE, pointing that the permissions to access the real application resource should be one thing, and the permissions to access the task resource are another thing. Then we need to find a way to practically make it happen. And I think AIF can be an option to explore in the context of ACE, for example. We did it before in other works.
Okay.
Thank you. You're next.
Okay, so this is another draft that really is in the informational space. We have been writing up co-op interactions for like 15 years now, and we have been doing this in 1,000 ways, all different. So there are things like UIs in there that are either notated as a number of UI path options or as a complete UI. We have to distinguish header and payload, request versus response. We have to put the method code somewhere and the response code. And everybody who does this invents a new variant of that. And well, that's a welcome variation, except some of us actually have to write CI scripts, and extracting information from such a form of presentation is difficult. And we are seeing a lot of documents out there that just don't survive CI. So recently, 99, 42, and 43 were published. I cared about 9942, and now I will write the RATA report for 43. Okay, so let's try to come up with something that solves like 80% of the situation. That's clear. Sometimes you really have a focus on demonstrating something that is a bit outside the normal situation. But normally what we really want is essentially the request line or response code, like in an HTTP message. We want to have options, but we don't want to have all these little options that create a URI. we can put those into a single composed URI. We probably have to tell the content format and then the actual payload if that is given. And of course, there's also need to write something about what particular kind of payload is being used there. So the media type may be useful there, but if you actually need to address a validator and say this is this and not this, then this also needs to be indicated somewhere. The payload, of course, depends on which format it is in. So it's CDN, CTN, whatever that will be called. For CBOR, it's obviously JSON for JSON. Core link format, hex, RFC 8710 application multi-part core. We have to cover all these examples. And we probably simply do a blank line as if this were HTTP. So yeah, nothing is surprising about what you are seeing here. So we immediately understand what's going on. And I think that should be the objective, that you can use this even without having read the RFC. So yeah, why does it matter? Because we want to check our specifications. I just found a weird place where I had written Boolean instead of bool. Yeah, somebody is trying to use this code and running into a problem that they don't understand. That's bad. But the point is not to create a big gating point here, but we just want to make sure that the CI will tell you when you have a problem, so you can fix that throughout specifications, little guide web pages, wikis, teaching material, and so on. So we have a few questions that we won't really have much time to discuss anymore, but that I would like to put anyway. So we are right now talking about a way to annotate application specifications. So ones where we don't reach into block headers or things like that. It is possible with the current proposal, but it's really focusing on application specifications. So if you have a specific example in mind where you want more from the notation, we would like to know. We would like to know if the current internet draft is clear enough, and we would be happy if you actually could apply it to examples in your document, so you will immediately know whether it works or not. And once a few people have done that, and the next version of this document is out, we will start putting this into tools like Ramdown, RFC, so that much of the CI will actually just happen without a lot of things going on. So Ramdown RFC already checks JSON because that's trivial, but we want to do it at this level as well. And we sure want to do it for HTTP at some point. And then when we have a little bit of experience with that and people generally like what they are seeing, we might want to adopt this as a working group document and publish it ultimately as information. Any comment on that? Oh, I should have said on the first slide that Jaime did all the work. So just standing here. So I saw a lot of nods.
Okay, so I think that's a really good idea to kind of formalize this in some way so that all the different variations out there get like a common version. May also be useful for like some diagnostic tools. I don't know, Wireshark or something like that they would adopt this. One question I have now, if we talked about before about the non-traditional responses where you maybe have like several responses. Do you have any like any thought about how you would represent that? Like maybe having multiple responses in an observe kind of situation?
Good question.
So like what comes to my mind is maybe have for request some kind of arrow pointing outwards and response some arrow pointing inwards, and you have several responses. You kind of can distinguish.
We already can distinguish requests from responses by the method code. So a request has a method code, a response has a response code. So that's a very simple syntactic way to change this. The easy answer to your question is we'll just write down multiple responses and you're done. And if we need a little bit more of linkability, we will Thank you.
I locked the queue after Martine. We are already out of time. Please be quick.
I'm very quick. This makes a lot of sense also as output for actual coop clients. Like AIO coop client currently just puts out like a made-up diagnostic notation, and I should just use this.
I will definitely have a look at this document. Just a question without looking at it before. Does this also support, like we did in 9953, that the payload is displayed in two different formats?
It's displayed
in two different formats. For example, in 9953, we had hexadecimal and then a human readable form.
That's actually a very good comment.
Oh. Okay.
Well, CDN is learning to do that. And so we probably want this in other situations.
There were also two more thumbs ups in the room from Esco and Ivo, I think. Count the third one as an individual.
So please,
please review.
On item 3 on this page, try applying it to the examples that you have today and tell us whether that simply works or more.
And please follow up on the list. I think we are at the end of the meeting. Thanks a lot to the presenters, the media takers. Many thanks. Thank you all for the great work and contribution. See you online.